All right. Good evening, everyone. Welcome again to our online data engineering meetup. So we are broadcasting live from three states, Brisbane, Sydney, and Melbourne. So first up, have to thank our sponsors. We have Snowflake, MongoDB, Fivetran, Canva, ThoughtWorks, and Instacluster. And we also accept questions from our Zoom channel, our data engineering Slack meetup, and then our Twitch channel as well. So if you have questions, just write them down in those channels, everyone. So our host and speaker for tonight, Dr. Jimmy from Brisbane Data Engineering Meetup, and Lace from Microsoft, Drew and from AWS, and Simon from ThoughtWorks. So here's our schedule for tonight. After me, we have Michelle from Yo Data, and then our first talk from Lace, then followed by Katie for our Data Invites conference. Next would be Drew from Amazon, and then lastly would be from Simon Ivory from ThoughtWorks. So I think we'll have Michelle from Yo Data to talk about Yo.
Sure. Thank you, everybody, for letting me give you some marketing. For those of you who haven't heard, we have a Yo Data conference this year. It is going to be online, and the poll results have come in. 49% people drinking water. Very important. Well done. And a cocktail made by robot. Excellent. I'm jealous. Sorry, I'm also easily distracted. So our online conference this year is going to be held over 3 days, but just part of the day each day, so you can actually get some work done, read your emails, and do all those other things that seem to come up when you are working from home, as I assume that probably a lot of people will be doing. And hopefully it will give people a chance to come along who don't normally get to attend conferences for whatever reason. Maybe you are not in Sydney, Melbourne, Brisbane, or maybe you can't get there because of caring duties or whatever. Our ticket prices are a nominal $100, but we also have a pay what you can option. So if people are experiencing some financial hassles in this current time, or their companies won't support them or whatever else, you can just pay what you can. And yeah, we hope to see everybody there. We have a day specifically dedicated to data engineering, as well as one for data science and one for machine learning and AI stuff. And hopefully we'll get a good crowd there and everybody can network, even though we can't meet up. So as we are doing now. So yep, that's it. Hope to see you there. There's the URL, yoconference.com/data or data, and you can find tickets from that. Thanks.
Right, thanks, Michelle. All right, I think we'll have to move on to our first speaker now. Lace, take it away.
Sure. Okay, let me just share my screen. All right. First off, thank you for having me. So I'm going to be presenting about DataOps for the modern data warehouse on Microsoft Azure. So this talk is actually a bit of it's a talk that I've given and in NDC and other places, and it's really meant to be a 50 to 1 hour talk. So there's a bit of condensing here that I've done specifically for this format where I have a little bit of over 25 minutes. So I did make it more sort of focus on the demo, because I imagine the data engineering meetup, lots of you are data engineers, so a fair bit of familiarity with the technologies already, and also the concept that I'm already presenting. So if you do want to see the full talk, there is also a recording of this on YouTube, which I can post in the link. So again, lots of demos, and hopefully by the end of the talk, you have a concrete understanding of how you would actually build a data pipeline according to the modern data warehouse framework, but also apply DevOps concepts to it by operationalizing this and making sure that you know how to move these data pipelines across different environments safely and repeatably. All right, so just a little bit about myself. So I am a senior software engineer as part of the commercial software engineering team in Microsoft. So I specialize around data engineering, as you imagine, Spark, Databricks, and Synapse. All right, so quick, very easy agenda. We're going to be talking about the modern data warehouse on Azure. What is this pattern? I think lots of folks here probably already heard this before or are familiar with it. And most importantly, how do you actually operationalize it? All right, so modern data warehouse. So before I talk about the modern data warehouse, let's first talk about its predecessor, the traditional data warehouse. And I'm sure lots of folks here are familiar with this architecture. You have your sources on the left. It's typically relational sources, maybe a bunch of CSVs. And you have a ETL process that basically takes these sources and transforms that into your dimension tables in your data warehouse. Then your data warehouse might be used to refresh a number of downstream consumers like data marts or probably even cubes or reports. What we're talking about when they say a modern data warehouse, we want to convert that into this architecture. So the modern data warehouse really is a response to the explosion of data, not just from a volume perspective, but also from a variety and velocity perspective. So not that a traditional data warehouse, which is built around relational stores, no longer fits the bill, right? So it revolves around the concept of a data lake, which can essentially ingest these different types of data sets in large volumes and large and very fast velocity. So you typically have an ingestion mechanism, which is the mechanism to use to ingest your data into your data lake, like exploratory analysis tool, and also a way to prep and train potentially machine learning models on top of your data. And obviously, once you have a good model and you have a good data set that's all nice and cleansed, you probably want to serve this in a way so that your downstream consumers can actually read and report against it. So here's a bunch of Azure services that is essentially mirroring the different functions within the modern data warehouse architecture. So you have Data Factory, which is your ingestion mechanism, but it's also used to orchestrate your data pipeline. For exploratory prep and training your models, you typically have a number of services that's available to you. So you have Azure Databricks, which essentially managed Apache Spark. You have HD Insight. If you are invested in the Hadoop ecosystem, this is a managed Hadoop platform. And you have Azure Synapse, which is in the latest release now not just SQL Data Warehouse, but a myriad of different other features like SQL On Demand or Spark On Demand. So now it solves the use case of exploratory analysis, but also prep and training. And serving, you have a number of different sources. Azure SQL is obviously a popular one, but also lots of open source databases can be hosted as a PaaS service on Azure, like MySQL, Postgres, and the like. And you also have Azure SQL Data Warehouse. All of this kind of revolves around your data lake. And for Azure Data Lake, for your data lake, we usually recommend Azure Data Lake Gen 2. So this is a layer over blob storage, which is essentially optimized for big data workloads, and also comes with a hierarchical namespace and file and folder level security. Okay, so for this demo, I will be using this publicly available API, which is essentially Melbourne parking data. So for the folks in Melbourne, did you know that you actually have sensors in your parking lanes, and that's all the data is actually available in a public API. So I'm just pulling from this API and going to be using in this architecture. So here is a typical modern data warehouse pattern implemented in an actual pipeline. So I'm pulling from the API using Data Factory, landing it into a landing table, and also cleansing and standardizing it with Azure Databricks. And then I have an interim schema where I'm basically putting the clean data in, but there might be some bad data that might not make it. So I also have a malformed record store, which I'm syncing those malformed records. And then I have a second Databricks job, which basically takes the data from the interim schema and moves that into the data warehouse tables. Then I'm using something called Polybase to load the Synapse or SQL Data Warehouse, as we called it before, And then that is what is used to drive a Power BI dashboard. All of this is orchestrated with Azure Data Factory. Now, there's also a number of other things here that I talk about in my other talk, where how you structure the data. So if you're interested with that, be sure to check out the other recording of the longer version of this talk. Okay, so that's all said and good. Oh, actually, let's first demo the actual pipeline so it's more concrete. Okay, so let's jump into the first part of the demo. So I am here in Data Factory. So Data Factory, if you haven't used it before, it's essentially, this is essentially your workspace where you can essentially drag and drop a number of activities here, and then you can build robust pipelines in this workspace. So very quickly, I have a set, I'm just setting a variable, which is a timestamp. And then I am doing a copy job. So the copy job simply is reading from that REST API as my source, and I'm syncing into Data Lake. So you can see here, and I'm syncing using that variable as the folder name. So the timestamp variable. What does that actually look like? So let's jump into Storage Explorer, which is basically a way to view Azure Data Lake. So you can see here that I have a folder, which is timestamped, and then I have a number of JSON file, which is basically the output of that API copy job. Nice and simple. And then I have a notebook job, which is basically a Databricks notebook job. So I'm calling a Databricks notebook and triggering that on a Spark cluster. So this is an on-demand Spark cluster. Now, the cool thing about this is that the Spark clusters get spun up when the pipeline runs and get torn down afterwards. So it's quite cost efficient in that regard, that you don't really have a Spark cluster running 24/7. So this is the notebook that I'm pulling. Let's navigate to that notebook. So if I go here in my notebook, now for the folks who've used, I think most of folks are familiar with this sort of notebook style of coding. And like if you use Jupyter notebooks, it's pretty much the same thing. And you can see that I'm using Python here, but Databricks certainly also supports Scala and also SQL and R. So the first part of the notebook, all I'm doing here is that I am parameterizing this notebook with something called a widget. So this is how you parameterize Databricks notebooks. And then passing in that file folder so that it actually knows where to look for the data. And I'm also passing in the load ID, which is basically the run ID of the pipeline. Now, the next series of code is I'm just setting a bunch of variables. So I'm building my file paths in that so that it knows where to find the data. And this is actually predominantly the majority of the code. So I am using this package, and I'll show you what's inside that package in the later part of the demo. But essentially, that package is a series of functions. And the series of functions are what I use to actually transform and cleanse this data. So one is I'm getting the schema that I expect. Oh, we have a little pop-up here. Let me just move that over here. And so I have a series of functions here, and then I'm just reading the data with a spark.read, passing in the file path. So of the file paths that of the different JSON schema that's sitting in blob storage. In the Azure Data Lake Gen 2. And then I'm calling standardized sparking _ bay data, passing in the Spark data frame, and then it spits out a tuple of data frames. So I have my transformed, cleansed data frame, and I have my malformed record data frame. And then I am simply writing into a Spark SQL table, my interim schema, and also syncing the bad data into the malformed record Spark table or Spark schema. So very simple, fairly straightforward. And then the second job here, if I jump back to Data Factory, is my notebook transformation job. So let's just go into that notebook. It's a very similar pattern. So this one, I'm just passing in the load ID. So I know exactly what load to, which records inside the interim schema to pick up. So you can see I'm filtering that by load ID. And then here, I'm just loading a bunch of dimension and fact tables. And again, I'm using that packaged again because I have all my data transformation logic inside this function. And I'm just loading a bunch of dimension tables. And here I am loading my fact table. So fairly simple, fairly straightforward way of actually transforming data. Now, finally, I have a stored procedure, and that stored procedure looks like this. So the stored procedure is, now for those who are used to loading stored procedures, dimension and fact tables, obviously you can make this more robust with like slowly changing dimensions and that sort of stuff. For here, I'm just truncating and loading the entire dimension. So fairly simple for this demo logic. But the magic here really is the external table. So this external table, for those who are unfamiliar with Polybase, is actually a pointer to storage. So you can see that I can define something called an external table, point that external table to data lake, and say, please load the data, please read the data in this location, the DW fact parking. And if I navigate into that folder in data lake, these are my Parquet files. So remember that I was syncing the data into my Spark SQL tables. And for those who know Spark SQL, that's really just a pointer to a bunch of Parquet files or whatever format you tell Spark SQL to write it in. So these are the Parquet files that underpin the Spark SQL table. And that you have data. So if I go and just query this table, we expect some data that's sitting there. There you go. Okay, so very straightforward pipeline. It's not that groundbreaking. It's the modern data warehouse pattern has been around for quite a while now. And what I find is that clients don't really have issues implementing the modern data warehouse pipeline. It's when you actually have to operationalize it. How do you actually move that entire pipeline across different environments, right? So there's this really great blog post by Data Kitchen, and it talks about different, how you would think about this in terms of the value pipeline and the innovation pipeline. So if you think about DevOps, it's really about the continuous delivery of value to your end consumers, right? So it's the merging of people, process, and product in order to accelerate the continuous delivery of value to your end consumers. Now, your value pipeline, that is your data pipeline, if you think about it, it is this delivery of value. It's taking raw data sets, transforming it into something that's valuable to your business users. But that's not the only pipeline. We have, there's a second pipeline called the innovation pipeline. And this innovation pipeline is what you use to update your value pipeline such that your data engineers' ideas or data scientists get deployed to your value pipeline, and therefore you're producing the best value for your end users. Now for the value pipeline, I am going to be using Azure Pipelines, which is essentially a CI/CD way of building CI/CD pipelines within the bigger Azure DevOps suite. All right, so let's jump into it. There's three components here. So we have Databricks, we have Data Factory. Databricks, you have your notebooks and that package that I showed in the notebook. You have your Data Factory pipeline definitions, and then you also have Azure Synapse. So your table definitions and your stored procedures and so on and so forth. So let's take all of that and break it down. So let's start with Databricks. So Databricks, essentially, the way that the package that I showed you is actually quite a fundamental way of actually transforming or packaging up your data transformation code. So data transformation code belongs in packages, not in notebooks. There might be, let me move this over here. So it might be quite obvious to software engineers, but it's not, to me, at least my experience is that it's not uncommon to see a notebook that has 1,000 lines of code. And the reality is that it's very convenient to write data transformation exploratory code in your notebooks because you can see the data in line with your code. But when you try to productionize this, it's really difficult to write high quality testable code when everything is in a notebook. So really, when I see this really long notebook with all your code in it, what I say is that you need to really think about which part is your data transformation code and which part is your data access code. And you want to rip out the data transformation code so that it's all encapsulated in a package such that you can write actual unit tests to run that's quote unquote out of workspace. You don't have a Databricks notebook environment in order to just run your unit tests. It also makes the development feedback cycle much faster because all of a sudden you can run your Spark code locally. So, and the other thing about Databricks is that it comes with a built-in version control mechanism. So you can basically wire up your notebooks with GitHub, Azure DevOps, or Bitbucket. And you can also use the Azure CLI or Databricks CLI to automate your work, which I will be using in my in my Azure pipelines. So let's have a look what that actually looks like. So if I go to Databricks, for one is that I'm in my notebook. And for one, you can either link it up here. So you can see here that you can click on link and just put in your credentials, your basically which Azure DevOps pipeline that your DevOps repo you want to link it up, and it will automatically sync that up to a specific branch that you tell it to. I haven't linked this one specifically because I actually use the CLI to pull down and commit that way, but that's more a personal preference than anything. And then you can also export this notebook. So this is more like the manual way if you want to do a one-off export. So let's navigate to this DDO transform package. So I'm going to go into Visual Studio or VS Code. And here it's actually is my Python's package. So you can see all my different functions all nicely sort of encapsulated such that all it really cares about is an input data frame and it outputs your good and bad records data frame. So when I try to run unit tests, it's fairly trivial, right? So I just instantiate a Spark session locally and I feed that Spark session into a bunch of unit tests. And the unit test basically just reads the JSON file, a predetermined local file that I have sitting in my oops, this keeps popping up. That basically is a local file that I have in my data directory right here. And I'm just calling this standardized parking bay data, which is the function that I want to test. And I have a bunch of assert statements. So now I can actually write proper unit tests. So if I do a make test, this will go and fire off my unit tests locally, and it doesn't have any dependencies on Databricks or even a Databricks cluster needing to be up and running. So it's nicely encapsulated like so. All right, so let me just jump back to the slides. The next thing I want to talk about is SQL or Azure Synapse or SQL Data Warehouse, depending on when you have experience with this technology. So there's this wonderful tool called SSDT or SQL Server Data Tools. And I think a lot of folks are probably already familiar with this tool, but it's essentially it's a tool that allows you to easily keep your database object definitions in your source repo. So you do want to version control all your SQL object definitions for sure, so that you can actually revert changes in case you have a bad deployment. And the other thing about SSDT is that it gives you this DACPack file, which is it's basically a package of all your object definitions. It comes with a tool called Schema Compare, where you can essentially have a choice of developing, say, on a dev server using SSMS or Azure Data Studio. And then once you're ready, you can pull down any changes to update your database object definitions locally, and then push those into SQL, into source control. There's also a CLI, so if you can use that to automate essentially in the deployment of your data object definitions. Now, for those who are more familiar with sort of DataOps specifically for relational schemas, there's really two fundamental trains of thought in here. You have the migration-based and the state-based way of deploying database changes. Now, SSDT falls in the state-based sort of tooling. And there's also the migration base, which is also quite acceptable way of actually deploying changes. Now, everything has trade-offs, right? SSDT is not perfect. For example, there's some problem. It's quite a little bit more difficult to say rename columns in SSDT. Then you have to chop that into two changes, or say add a non-nullable column. So there's ways around it, but certainly it's not sort of the silver bullet, if you know what I mean. The same with the migration base, right? So the migration base also has some issues with it. Unfortunately, I don't really have time to go into the details of each and the details of the differences between the two, but just know that there's two sort of trains of thoughts of deploying changes into SQL. So let's just have a quick look at SSDT. So here I am in Visual Studio, and Visual Studio 2019 comes with SSDT out of the box. But if you are in 2017, I believe you have to actually download this as an external package. So here you can see that I have already all my object definitions in Visual Studio. So all I need to do really is to just commit this into source control. And now all of a sudden, all my table definitions and stored procedures are versioned up. The other thing that I want to show you is that if I do a build, this actually validates that all my objects definitions are consistent. So it creates this thing called the DAC pack. And this DAC pack is what I'm going to be using to deploy across environments. So that's basically SSTT, and obviously there's a lot of more functionality here, which I unfortunately don't really have time to talk about. But let's move on to Data Factory. So Data Factory, as you've seen, this is your data pipelines. And the cool thing about Data Factory is that it has the ability to integrate with your source repo, so GitHub or Azure DevOps, and when you integrate with Azure DevOps or GitHub, it automatically saves your pipeline definitions into a specific branch, or which branch you tell it to. So once you have these definitions in Git, your data pipeline definitions, this is kind of how you deploy it across different environments. So first you have a dev branch, so this is where you'll be working on. Then you create a pull request into your master branch, so what we call the collaboration branch. It could be master, it could be something else. And then you do a publish. So you publish into your dev data factory. So this is a manual publish. By publishing, Data Factory automatically creates a branch called ADF publish branch. So this publish branch has all your ARM template definitions. The good thing about that is now you have your ARM templates, and you can use this as an artifact in a release definition, and then just create a release, parameterize it with the appropriate parameters, and deploy it to the relevant data factory. So test, production, QA, and so on and so forth. So let's have a look what that actually looks like. So I'm gonna go and navigate to Data Factory. And here's the sort of the landing page when you open the Data Factory service. And if I go and set up code repository, this is what you have. So if you go to GitHub, you can go and fill up your details, and then it will go automatically sync that up if you have correct rights to that specific repo. Now, I've already done that to my Data Factory. So you can see here, I can see here that I am already wired up into a GitHub repo, and I'm currently in my Lace demo change branch. Now, the Lace demo change branch is where I do all my changes. And one of the changes that I want to do is make this hello data engineers move across different environments. So I've added that hello data engineers as the description. Now, the other thing I want to show you is that if I swap over to the master branch, this is the branch where you can actually publish changes into your dev data factory. So you have a publish button here. Once you publish the changes, so I'm going to flip into GitHub, you can see that I am in the ADF publish branch, and I have the ARM template definitions here. So for those who are not familiar with ARM templates, this is essentially the infrastructure as code. So all your data pipelines are defined in this ARM template, which you can use to then deploy across different environments. Okay, so I'm just gonna pause here and just check the Slack channel for any questions. Nope, there seems to be no questions, but feel free to add or
there are questions in the Q&A if you would like.
Okay. I think I was checking the Slack Slack channel. Okay, let me see how I actually
I can tell you them. So someone is interested to know how frequently you can get Data Factory to run ingestions from the same data source. Is it close to near real time, so less than 5 minutes?
Right. So, so Data Factory, you have different ways of triggering Data Factory runs. So there's an event-based trigger. So in which case it triggers when an event happens. So for example, if a file lands in blob storage, for example. So it will trigger whenever that happens, that event happens. And you can specify the level of concurrency. So the number of pipelines that you want to run in concurrently. But you can also schedule it on a scheduled basis. I have to check what's the sort of the minimum amount of time, like the sort of the smallest time interval. You can do that with using a scheduled based trigger. There's also a tumbling window trigger, which in that case, I think it's a 15-minute interval for the tumbling based trigger. So you have 3 types of triggers in Data Factory.
So many options.
Yeah, so
I hope
sure.
that answers your question, anonymous attendee.
Anonymous attendee.
And then there's one from Berger. Hi, Berger, who likes to run CI/CD in Linux containers. When will SQL package.exe work on Linux?
That's a great question. I don't know the answer to that, unfortunately, but I heard of some potential migrations, but unfortunately, I can't really give a firm date with that. So, yes. Anything else? Okay. All right. So I'll just jump back into the slides. Well, thank you for those questions. Now, I think we have almost everything to do a CI/CD deployment. So this is how the flow is going to work. Now, this flow is obviously a demo flow, and some folks in customers have even more complex CI/CD pipelines. But this is just something so that we can communicate, like we can show a CI/CD pipeline. So don't think that this is the CI/CD pipeline for every single use case. But this is typically what we see. So we have a sandbox environment. So developers develop on this specific sandbox environment. You have a feature branch, which is short-lived if you're using trunk-based development. And then once you've completed your changes in that feature branch, you raise a PR to master. This will then trigger a validation pipeline. So basically run your unit tests, your linting, your DAC builds, and so on and so forth. And then you can once the PR has been validated and has been completed, so a code review process and so on and so forth, this then triggers a commit into master, which will then trigger a build and publish artifact pipeline. So this will then build all the necessary artifacts and publish them as a build artifact. Finally, you have a release pipeline, which will then release across different environments. So dev, stage, and production. Now, a big ask that I find is that you want to somehow control these releases. So there's definitely a way to do that with using approval gates. And the approval gates basically is a way to say, wait, I need approval before I deploy to the next environment. And typically, this is also where you would do your integration tests. So your dev and stage is where you can run your E2E tests or integration tests. So let's jump right into the demo. So if I go into my, let's move that over here. So I am in Azure portal, and you can see that I have three environments: dev, stage, and prod. And they already have sort of the base infrastructure and a version of the data pipeline running. So you can see that all my definitions are here. And if I jump into the dev data factory, I've shown you that change. I've already saved that into my demo change branch. The idea is that we'll find that it gets deployed in this staging data factory. So you can see that this is my stage data factory. Now I've already raised the PR, and this PR, you can see I have a demo change. And by raising this PR, you can see that it's triggered this pipeline in Azure DevOps. So it's triggered a job, and it's triggered a specific pipeline. So if I just jump back into that PR, and let me go and merge this pull request. Yep, I want to confirm this merge. Now this merge will then trigger a second build pipeline. The other thing that I find folks also sometimes miss is that you now need to flip over to master in the dev data factory. Remember, you've just committed the change into master by merging the PR. Now we want to publish this into the dev data factory. So usually you probably want to trigger the run first and then make sure everything's good as a developer. And then we go and hit publish. So this publishes basically that change into the deployed dev data factory. And aside from that, most importantly, it updates the ADF publish branch. So if I go, yep, that's the change with the description, it's going to go ahead and gather the changes and then publish to the dev data factory and update the ARM templates in that ADF publish branch. So, okay, so while that's doing its thing, I'm going to flip into Azure DevOps. So this is my Azure DevOps pipeline, Azure DevOps UI or portal. And you can see that I have a pipeline, your CI artifacts. So this is the pipeline that produces the build artifacts. And you can see that it's gone and triggered off a change. So while that's, let's just have a look at what's that doing. It's basically publishing your Python packages, the static artifacts, and your SQL packages. So your DACPack basically. And if I jump over here, you see that's publishing and it has generated the ARM template successfully. And hopefully this will soon complete. It should complete in the next few minutes. So while that's running, and before I jump into sort of the details of this pipeline, I will go and first give a little bit of a primer to the folks who are not really familiar with Azure pipelines. And I can see that I'm almost out of time, but I'll just be very quick. So first you have a trigger. So this could be a commit, a PR, a pipeline, a previous pipeline completing. This will trigger the pipeline. And within the pipeline, you have a series of stages. Now these stages typically would run in sequence. Within the stage, you have a job. So the job basically is what actually runs on a specific agent. So a Windows agent, an Ubuntu agent, or a Mac agent. And then the jobs usually run in parallel, unless you have some sort of dependency explicitly defined. So for example, here I'm saying this job depends on this. And basically this job has a, within the job is where you would define your tasks. So the actual steps that actually run within the job. So for example, a task that might build an artifact or publish an artifact, or you might even have a deploy step within that actual pipeline definition, step definition. Now, just to show you what that looks like in an actual YAML file, because all of this is defined in YAML, it's like you can say trigger to master, you can define a bunch of variables here that specify basically the default agent pool. So in this case, it's Ubuntu, and then that's when you define the series of stages, jobs and steps. So if I go back into that pipeline, hopefully that has completed. Yep, that has completed right there. And you see that it has triggered a release. So this release is a multi-stage build. So you can see that I am a series of stages which deploy across different environments. So dev, stage, and production. And the first part is basically deploying to Databricks and Azure SQL. And the staging environment, staging step basically is deploying to Databricks, Azure SQL, and using the ARM templates from the dev data factory to deploy to the staging data factory. As part of the staging, deploy to stage, I'm also running my integration tests, right? So this is actual tests that actually triggers my data factory pipeline, so the one that I actually deployed, and make sure that the output of this data factory pipeline actually has the data that I expect. And finally, I have the deploy to production, which is basically the same steps. Now, the other thing I wanted to show you is the approval gate. So you can see that I have one approval needs your review. So before deploying to staging, you can say, hey, please put a gate here so that a series of people can review the changes first. So I put myself as a reviewer. Person A could go and review that. I say, yep, approve, and it goes and triggers the rest of the stage. Now, the way you do that, and this will go and run through the rest of the pipeline. So, but while that's happening, if I flip into environments, you can see that I have a series of environments here set up. And the cool thing about this is that it tracks all the different changes that's happened to that environment. So you can see all of these jobs is the ones that actually deploy to that specific environment. So it's a logical grouping of changes. So you can really hone down of the different commits that happens across different environments. And the way you would configure approvals is you just go here into approvals and check, and you can say, yep, I want Lace or whoever to approve changes before deploying to this environment. Okay, so I think I have like 2 minutes left. I don't think I have enough time to really go into the detail sort of pipelines. So what I'm going to do is all of these pipeline definitions are in GitHub. So if I jump into here, so this GitHub, basically a GitHub repo, the Azure Samples Modern Data Warehouse DataOps, has all the pipeline definitions in your DevOps folder. So if you're interested, please check out these pipeline definitions and you can see everything that's used to actually deploy this. And the other thing is that all of the definitions and pipeline code and even a deployment script should all be documented in this Azure Samples repo. And let's just have a look at our pipelines. Hopefully, at least the staging is complete. If not, that's okay. Okay, so it's just deploying the data factory bits. That's just an ARM template deployment, so I'm hoping that's pretty quick. So I'll just quickly go back to that once I am done with the slides. I'm already at the tail end. Now, all of these learnings, I actually kind of didn't really go through them in my actual presentation, but these are the key learnings that we've found while building data pipelines within customers. Now, I go through this in detail in my longer version of this talk. For example, data tiering, which how do you structure your data within your data lake, where we talk about bronze and silver and gold data sets. Where do you validate in your pipeline, and why you don't want to validate before your bronze, and how do you actually ensure that your pipelines are replayable so that you can recover from failure. Like failure is inevitable. And the reality is that as long as you can recover from it, then typically that's the best thing you can do, is essentially being able to, your time to recovery is minimized. Also, obviously automate your deployments with CI/CD, ensure your data transformation code is testable, which I showed in the Databricks notebooks. Secure and centralized configuration is something I also didn't talk about, which is basically how you secure and centralize your configuration with something called Key Vault, and how you actually flip how do you actually manage this across environments. And also monitoring, which is super important once you actually deploy into production. How do you know that everything is functioning correctly? So infrastructure, pipelines, and your data. How do you know that you have the correct data sets in production? As I said, all of this is in the repo that I just showed you, and that's pretty much the end of my talk. But before I leave and hand over, let me just check. Yep, Data Factory has been deployed. So if I go and refresh this, hopefully we should see, why is it refreshing? We should see our change. Whoops. There you go. So I'm in the staging Data Factory, and we have our change in the description. Great. And that's pretty much my talk. And let me just double check quickly the Q&A if there's any additional questions.
There are some questions.
Cool.
There's one who's come from another channel, which is how do we access data sets from different resource groups inside Databricks?
Okay, yeah, that's definitely possible. So if you have a data set, for example, in a different storage account, for example, it doesn't really matter where the storage account in terms of resource groups, you technically can access storage from a different region. Say you deployed it, say in East US, and then your Databricks instance is in Australia East. That's not recommended. You can still do it, but imagine the data transfer cost would be very expensive. But basically you can, as long as you have this connection string to your storage account, you can access data in your Databricks environment. There shouldn't be any limitations whether that's deployed into the same resource group or not. I hope that answers the question. There's different ways to do it. You can either provide your storage using putting it in the Spark Conf, or you can use a mount. So you mount your data lake Gen 2 or blob storage into the Databricks file system in DBFS, and you use the Databricks CLI to do that, which is what I'm using in my demo. I can also quickly just try to look for that code. That should be in one of the Databricks notebooks. So if I jump here into samples, Databricks and notebooks and setup, and the setup code is basically what does the mount. So you can see that I'm mounting a storage container, and I'm just passing a bunch of configs. So basically the configuration is all your secrets. So your service principal ID and service principal key, which that service principal should have access to that specific storage account for this to work.
Awesome.
So this is like one way to do it.
There's two more questions in the Q&A, but in the interest of time, maybe you can go in and type the answers to those.
Yep, no worries.
And then we can truck on. So I'll handball back to Francisco, the MC. Thank you very much.
Thank you, Lace, for that very informative discussion. So now we'll move on to Katie to talk about data engineering vibes for us. Let me just share my screen.
Awesome, thank you. I just would like to do a call out for the Data Engineering Bites, which is going to be our virtual conference focusing on real world data problems. It's going to be a two half days over the 20th and 21st of August. We're going to be focusing on data at rest, data in motion, and data for machine learning. So if you do have anything you'd like to submit, the call for papers is currently open and will close on the 30th of June. And I'd just like to do a huge shout out to our sponsors, which are Snowflake, MongoDB, Fivetran, Canva, ThoughtWorks, Yao, Cloud Shuttle, and Instacluster. So if you do have any talks or would like to join us, the tickets are now available and the call for papers is now open. I think that's it from me. Thank you.
All right. Thank you, Katie, for that. I think we can move on to our next talk, which is from Drew from AWS.
Thanks,
Drew?
mate. All right, I'll just share my screen. All right, we're looking okay.
Yeah, just full screen it, Drew.
Yeah, there we go. We can just move this out of the way. All right, hey everyone. My name's Drew Paterson. I'm a solutions architect here at AWS. I've been with AWS for 3 years, and prior to that, I spent about 10 or 11 years working in telecommunications across Nokia and Alcatel-Lucent, if you're familiar with those companies. It's my pleasure today to talk about Amazon AppFlow, which is it's a new service, and it helps automate bi-directional data flows between AWS and your SaaS applications. And it's targeted at the no coding audience. Now, I know this is data engineering meetup, so let's find a way if we can make it more relevant tonight. But again, it's about making it easier to get that data into your data lakes, for example, or your data warehouses, and perhaps do some cool things. So to move into the next slide, why did we create, sorry, it skipped one there. So today we're going to look at why did we build AppFlow, how it works, the current integrations that it has, common use cases that we're seeing customers use it for. I have 2 demos, and we're going to look a little bit at the roadmap. And then the question that I always get asked is, how does this compare to your other AWS services? So we'll take a quick look at some other data ingestion services and how they might be a little bit different. And then hopefully we'll have some time for some Q&A. So why did we create AppFlow? So it's pretty, I guess, common against all of our customers and your businesses today that businesses are looking to create, better insights with their data. And at the same time, the number of SaaS applications that companies are looking to use so that they can decrease their operational burden is also increasing. So I in terms of your IT real estate, I'd probably see that 30 to 40% of SaaS apps will become a part of your IT real estate within your company. AppFlow was also designed to help with operational efficiency. So as data engineers, I think we're pretty familiar with having to create custom connectors to all of the different ecosystems out there. So we're looking to try and find an easy way for those connectors to be supplied by AppFlow so that you don't have to repeatedly create them. We're also looking to empower citizen integrators. So not just, sometimes, the data engineering team, we're pretty rare, we're pretty awesome, we're pretty special, but we can become a bottleneck. So we're looking at how can people in the lines of business who may not have that competency get access to the data they need to get insights quickly. And then finally, we want to create an easy way to achieve this with security. So we'll look at how we put layers of security around importing data from your different SaaS applications and storing them in a governed way on AWS. So this is kind of how the flow works. And I won't spend too much on this slide because we'll see it in the demo, but essentially you pick a source and which that will be your SaaS application. You pick a destination, which can be one of 4 at the moment, which could be S3, Salesforce, Redshift, or Snowflake. You specify how you want that data flow to be triggered. So it could be event-based in the case of Salesforce. you could schedule it from a minimum or a maximum frequency of 1 minute all the way up to weekly and monthly. And then you can also do an on-demand. So you could be in the console, you could build a flow and then click, run now. It has some, I would say, limited but pretty powerful data munging, wrangling kind of capability. So you get to do key things like map fields, pick what you want to ingest, not all data, add some filters, date ranges, different mask sensitive fields, and that sort of thing that you would expect from a tool like this. And then you can activate it. So once you've defined it, you activate it and it's there and it's running. These are the SaaS applications that we've integrated with and supported at launch. Today, we'll be looking at a few Salesforce demos, but there's a couple in there that we're looking to grow and expand upon. So all of these are integrated today, but we've got even more in the pipeline. And if you see the little purple box above Singular, Trend, and Snowflake, these are also representative that we currently have private link enabled for these particular SaaS applications. This is what private link is. So private link is about not going over the internet or transiting the internet at all. It's all about having private connectivity between your SaaS application who could be running in AWS. So imagine this is Salesforce over here on the right-hand side. And then this is your AWS environment on the left-hand side. AppFlow will actually take care of the management, of that private link endpoint, and will ensure that all of your traffic traverses via private AWS network connectivity. Some example use cases. So, I won't read them out in detail, but you can get data out of Salesforce and into your data warehouses. You might want to pull some data and events out of Slack, do some sort of intelligence over the top of that. You can integrate and connect to your Zendesk. Oh, here we go. And then you may want to use it, and this is where, from a data engineering perspective, I think it would be very powerful, and we have seen it save a lot of time and complexity for our customers, is hydrating your data lake. So that might be something you might do as a one-time, as a data engineer, set that up, enable it, and then move on to the next valuable thing that we do. So the first demo, it's going to be pretty simple. So what I've set up is a S3 based website. So S3 is a object store, but it can also be used to host websites. I've put our Amazon CloudFront, which is our CDN, in front of it. So it's just a basic HTML file with some CSS embedded that will load into a customer's web browser. Off the back of filling out that feedback form, when they hit submit, that will create an API call to Salesforce and create a case. So if you're familiar with Salesforce, feedback form data can be captured in a web to case type of methodology. On Salesforce, we have installed the AppFlow app. So Salesforce has this concept of embedded apps. It's a one-time thing. You set it up as a Salesforce administrator, and then that enables AppFlow to either run bulk, batch, on-demand kind of transactions, like and ingestion of data. But it also, within the instance of Salesforce, enables events to be processed. So as that customer hits the feedback form, within a few seconds, AppFlow is aware, and that data is sitting in S3 or potentially over in Redshift. So let's have a quick look at our Redshift cluster. So I'm just using Agility Pro here to connect. I've created a table, just called Salesforce cases, pretty simple. I believe it's currently empty. Yep, so I don't need to truncate it. Very, very simple schema. It's the sort of thing you have to set up first. So currently at the moment, AppFlow will not create your tables, but obviously it would be a one-time thing for maybe your SQL Server analysts to do. Once you have that schema set up, we come into the AppFlow console and we create flows. Now, I won't go through connections too much and how to set that up, but just know that we do store and enable you to store your Redshift credentials and also your sales. In this case, I've predefined Salesforce connections, and that's stored in AWS Secrets Manager in a very secure manner. And it's as simple as your business user coming across here and creating a flow. So we'll call this Salesforce to Redshift. And if you want, you can encrypt this data using your own customer managed key with KMS. And what that means is, as AppFlow pulls the data out of Salesforce, if it needs to stage data in an S3 bucket within its service account, it will use your CMK, which means it's encrypted with your keys, and you retain full control over that data as it may temporarily reside in the AppFlow service. But it also means as the data lands in your S3 bucket, because it will need to be staged there before the Redshift copy command, it's also encrypted with your CMK. So that's a really powerful security feature if it's of value to your use case. So here we're going to pick a source of Salesforce. And like I said before, I have my connection predefined, but if you were to create a new connection, you just pick production, maybe give it a name, and it just launches the Salesforce. Oops. Oh, it's already pre-registered. It didn't bring it up because I've already my Salesforce credentials embedded in my browser. So watch that. If you have multiple Salesforce environments, just be careful of what may be cached and pre-populated. I'll switch that back to this account because I don't quite know which one that would be. I don't want it to be my Amazon one. And then we're going to do an object load in this case. So I won't show it for the events, but you can also pick event sources that will respond in near real time. But we're going to do more of a batch-led load in this time. And we're going to bring over our cases. So you can see here, we have our full list of Salesforce assets that we're able to sync pre-populated here. We want to put that into our Redshift cluster, and we pick our connection. As soon as we pick the connection, that does a query against Redshift and populates our tables. So here you can see that our Salesforce case schema has been discovered. And here is how you may want to handle error. So if for some reason the flow fails and doesn't work, you can choose an S3 targets for that load to stage into. You can pick to run on a schedule. So if you do pick a schedule and you're running something like every 5 minutes, it's only going to transfer your new data. But if you move it to a less frequent type of load, you can choose to also transfer all data. So you might want to do a bulk load monthly, but for something that happens at a higher frequency, you might want to only look at new data, and you can specify the window in which that flow might be active. So we're going to just run on demand today. So here is where we map our fields. So there's a lot of fields in a case. We're only interested in 4 of them. So we're gonna pick our case number. We're gonna pick the name, and we're gonna bring the subject and also the description, the case description. And we map our fields, and then all of a sudden it does a query into that table on Redshift, and we kind of just play that mapping game, right? So we map case number to case number, name to name, subject to postcode, because I'm using the Salesforce subject field as a postcode collection method, and that'll make sense once you see the feedback form, and then feedback description. So we map those fields. Here we can choose to do some kind of data modification. So maybe we don't want the full name to come through because that's sensitive. So we might want to mask some values. So let's mask the first 5 characters of everyone's name. And if we wanted to, we could also, if we had a 5th field in our destination table for Redshift, we could add formulas and maybe concatenate 2 fields together to create a whole new field within Redshift target. So there's some primitive kind of data munging things here that will be of value. You could do some validations. So we might say, we want to only pick records where the subject is not null, right? So if the values are missing or null, let's ignore that record. You can also terminate the entire flow if something's not quite right. And then finally filters. So let's say we're only interested, if this in the subject field, because we're collecting postcode, we're only interested in if it's exactly the postcode of 2000 for Sydney, because we don't really care about the people in Melbourne. We want to make sure that Sydney's covered, and we only want to look at Sydney data. Okay, so that's our flow. It's all set up, and we hit create. and then run. So that'll take about 10 seconds. And obviously, depending on how large your data sets are and how much you're pulling across, that'll impact how long this takes to run. All right, so that's run successfully. We'll go back to our select statement, and you can see here we've pulled across only postcodes of 2000. We've masked the first 5 characters of our full name, and we have our feedback descriptions in here. But that's really great. That's great for all of our SQL people out there. But we're data engineers. We want to do some more fun stuff than that. So that's why I created this second demo. So what we're going to do this time is, instead of directly loading the data into Redshift, we're going to put it into our data lake, and we're going to put it into an ingest path, and that's going to trigger a Lambda function. That Lambda function's written in Python, and I'll show you a little bit about how that works. It'll reach out to Amazon Comprehend, which is a fully managed machine learning service that we have. It's in our AI category of services, and it will detect the sentiment. So in the feedback form with that that text description, we're going to send that over. And Comprehend's going to tell us if it was a positive, negative, neutral, or mixed sentiment. That's going to then land into a serving layer bucket, of which Amazon Athena is going to do some queries across. That's going to surface to our BI tool called QuickSight, and then we're going to get pretty pictures. So everyone loves pretty pictures. So we move on to the part where I need your help. So if you can go on your phones to tinyurl.com/appflow demo. I'd love for you to fill out this feedback form. It should only take about 10 seconds. If you put your actual email address in here, you'll get an email from Salesforce. Just be warned, and it will have my email address in there. So if you ever need to reach out to me and bug me, you will get my email address if you put a valid one in here. If you put a valid Australian postcode in here, it'll mean that your hometown will get plotted on this pretty little visualization over here. And then feel free to be emotive about the description. If you want to write something positive, negative, neutral, mixed, if you want to write something funny, feel free to have a crack. I will show you what our dashboard currently looks like. So currently I've got 3 kind of feedbacks in here that I wrote before. This should increase dramatically. The flow that will be gathering and tracking all of our information will be this event-based one here that's in progress. If I have a look at the run history, okay, so I can see that there's been 3 flows are currently in progress here. Someone has already filled out their feedback form, and if I update that, looks to be an error with one of them. So some of them are completing. Oh, we've had a lot complete, and I'll have to go back and have a look at that one with that small. Oh no, it's completed. Cool. So we're looking good. We've got lots of people answering feedback. While we wait for those to finish, I'll quickly show you the Lambda function. So Lambda is our serverless compute engine. You get charged. You get over a million. You get 1 million invocations a month for free perpetually, but once you go past that, you get charged per 100 milliseconds of computational time. You can see here that this is the trigger that launches the Lambda function. So if anything lands in this particular S3 bucket with this particular prefix, it'll trigger my Lambda function. And I'm leveraging Lambda layers here. And what that is that enables you to package your own runtime. So Lambda supports a whole bunch of languages and applications. But I'm using Python, but what I've got here is our AWS Data Wrangler package. AWS Data Wrangler is pretty cool. If you're in data science, or you're a data engineer and you like to play with pandas, this really augments pandas really nicely. It pre-packages pandas, Apache Arrow, the Boto 3, which is the Python SDK for AWS, S3FS, and a bunch of SQL connectors, all in a nice little package that you can throw into your Lambda functions. It helps you do common things like push, pandas data frames around into Redshift, Glue, Athena, EMR, QuickSight. So if you want a shortcut to, an easy life working with pandas and AWS, then you can put this into your SageMaker notebooks and also into your Glue Python shell environments. So coming back to that Lambda function, this is the world's worst code. I'll tell you up front. I put it together just for you guys. But basically what happens is as that file lands in S3, it'll create an event. And the event header will contain information about that S3 object. So the first thing that I do is I get I open up that file from S3. If we have a look at the function that does that, right? I create, using the Boto3 client for S3, I get the object from S3 using my Lambda function. I open up the body. I send it back down to the rest of my my work here. I then extract some fields from that file. So I want the contents of it. The most important one is obviously that feedback description that was submitted as a part of that form. Once I have that feedback description, I want to send that to comprehend. So I've got a little function up here, and this is how easy it is to work, with a lot of these AI/ML services that are managed. So it's just like 3 lines of code, right? I create a client, I give it my feedback description and the language that I think it is, and it will return back that, positive, negative, mixed, neutral response. Once I have that field, I was playing around for the first time with Data Wrangler. You create a data frame, okay? So this is just normal data frame with these different fields. So we've got the case number, description, the date, the sentiment, and also the postcode. And then we write that to S3 in Parquet. So again, Data Wrangler helps us write data frames to S3 paths or Redshift destinations, for example, really, really simply. All right, so now that I think enough time has passed, let's see what's happened here. And so what QuickSight, is doing is it's actually doing Athena queries. So it's just a serverless managed Presto engine. So if you're familiar with Presto, Athena will use the Glue catalog's Hive metastore. So the data catalog that you have, it has access to the databases and tables defined in there. And then you can do queries across your S3 data without it having to leave it. If we refresh this page, it should only take a few seconds for those queries to be redone. And hopefully we have lots of different postcodes and a mixture of sentiment. So we've had 24 feedback forms filled in. And wow, we've got a real spread of people. So we have some people, one person in Western Australia, welcome. And then we have little clusters all over the place. So that's pretty cool. We've got people representative from all over Australia. Welcome everybody. And I'm sure there's people outside of Australia too. Apologies that this only works for Australian postcodes. And you can see here that maybe we can have a look at how this works. So Drew rocks, that's positive. Yes, I agree. Oh, here we've got this really stinks, ouch. Okay, but I get it. You just wanted to get the negative there. And then a few neutral. So I heard Kevin Bacon had coronavirus, but now he's cured. I don't know. Is that positive? Is that neutral? I don't know. Maybe it's mixed. So, okay, what have I got? 2 minutes left. We'll head back to the deck. Okay, so what's available now? So we have those sources that I was talking about before and destinations. We have private flow support for Trend Micro, Singular, and Snowflake. We have event-based triggers for Salesforce and some basic data transformations. If you're going to use this in Ango, if this sounds like something you really want to use now, it sounds like a great thing. It is, but just be aware that it is in its infancy. This service was launched in April, so we're still waiting for public APIs to be made available to support CloudFormation and also obviously your SDK integration. We do have private flow for Salesforce coming pretty soon. CloudWatch integration isn't there yet. So if you're looking for CloudWatch logs, if you're trying to do deeper troubleshooting, not there. CloudTrail is though. So if there's very clear, audit trail of who's creating flows, who's triggering them and what. So there's the audit and security is there, but in terms of debugging, it's not, I would say, as where I would want it to be just yet. CloudWatch events. So, status updates and automation around, has your job succeeded? Has your job executed? Did it succeed? Those sorts of automations are coming very soon. And then obviously additional filters. If you are going to use it at Ango and you're going to use it at work, feel free to reach out to me. more than happy to keep you under NDA. I can share, more information. Okay, so which service do I use again? One of the, proudest things as an AWS solution architect, but also one of the challenging things is staying across, the 190 plus services that we have. It's a very broad and deep platform. Now, if you were to look at the data space in terms of moving data around, we have AWS Data Sync. Now, that's all about moving, masses of data between file systems. So if you're on-prem or in some other environment, you have, NFS or SMB file stores, and you want to get them into AWS or back the other way. And your targets with data sync are things like S3, EFS, which is our managed NFS, and then FSX for Windows, which is your native Windows SMB implementation, but fully managed. AWS Glue, when you think about that, think about serverless ETL. So if you want managed Spark clusters that support PySpark and Scala, or if you want a Python shell environment that isn't a clustered environment, so you've got your Lambda for really small jobs, you've got Python shell for kind of your medium jobs, and you got your clustered Spark clusters. And then recently, you also created Spark Streaming. So that supports a bunch of sources. So think about Glue as an ETL. Database migration service. So that's all about helping you migrate your databases into AWS, or to have continuous async replication from your databases into EDS, into AWS. So that could be to for historical reasons, to land, CDC, and you can do all your type 2 histories off the back of some other solution like Databricks and pick that up, or Glue. But database migration service will help you do that heterogeneous database migration. So from Oracle to a Postgres, or your homogeneous migrations. And then Amazon Event Bridge. So Amazon Event Bridge is an evolution of CloudWatch events, which we came out and rebranded as Event Bridge, and just made it simpler for customers to use and have an event bus, a fully managed serverless event bus that facilitates the creation of your event-driven applications. So whereas AppFlow is about data flows and API-driven integration, Event Bridge is targeted more towards developers and developer-centric, and it's all about events, not necessarily bulk data transfers. So that's me. I hope that helped. If you want to know any more about what I built today, I'll probably be turning this into a blog post, but if you reach out to me via my email, I'm more than happy to share with you what I've built. Oop. Any questions?
Yes, there are questions.
Okay.
So first one is this similar to Power Apps on Azure? Nothing like being asked about how your stuff relates to the other guy's stuff.
I haven't used Power Apps, so I wouldn't be able to say, unfortunately. I don't know if Lace has used it and would be able to comment. Yeah.
So it's still a mystery. Okay. Then there's 2 questions. Any view on version controls the flows?
Yes. So I would imagine once we have that, so in the next 2 to 3 months, we will have API support and and that will mean that we'll also have CloudFormation support, and I'm assuming, the likes of Terraform will enable you to do that. So that'll mean that you can, fully define your flows as code and then import them. But yeah, I acknowledge at the moment, it's all console driven.
Cool. And then the last one is there any best practice you can suggest on schema changes?
So at the moment, it doesn't support adding new fields. So that's something that is in the roadmap. So we'll be looking at, if new fields are added, how do we detect that? How do we incorporate that into the flow? And also deletes as well if you lose a field. So yeah, that's coming, but at the moment it would be a manual effort. So if your schema changes, you would need to look at how that gets propagated into your flow.
Cool. I don't know, Peter, if there are any other questions come across from the Slack or from Twitch.
No, all good. Thank you so much, Drew.
No worries.
Who have we got up next? Simon Aubrey. Francisco, did you want to do the intro?
Yeah, all good. Peter, yeah. Our next speaker is Simon from Southwark. So he'll talk about Kafka and socks. Go ahead, Simon.
Hey, thank you. Just give me a moment. I just need to share my screen. Hopefully the technology is going to work. So can I just get confirmation that, hang on. Can you see something on your screen at the moment?
Yes.
Fantastic. Well, thanks very much for inviting me along today. It's great to be part of the data engineering community and have the opportunity to present. So I'm conscious that I'm following on the footsteps of some incredible presentations. Lace took us through the importance of taking the power of data engineering and solving parking challenges. Drew took us through how to leverage data engineering challenges when you're talking about SaaS products. But today I'm going to solve the most important problem, and that's how to pair socks using a combination of Kafka and actually solve that age-old problem of, can I arrange my sock drawer with event streaming paradigms using Kafka and Kafka Connect? So probably before I get too ahead of myself, I should just do a quick introduction. So I'm Simon Aubrey. I'm a principal data engineer at ThoughtWorks in Sydney. So my day job is designing, building sort of enterprise, typically event-driven systems. And generally they have elements of cloud or IoT, but there's generally a move towards event-driven architecture. So I'm here today to share essentially a small project that illustrates some of these problems, but also shows some of the solutions when you actually build highly available, large, distributed solutions using event-driven architecture coupled with machine learning vision and event-driven architecture. So like I said, today I'm using event-driven sock sorting. So this is actually an adventure in pairing socks. And if you're having trouble with my accent, I'm literally talking about pairing socks. So can I use a combination of open source technologies to receive sock classification images from a camera, perform some time window-based stream transformations to find pairs of socks, and do this completely offline and standalone. And if you're curious, all of this code that we're going to be using today, it's all open source and it's written up at this GitHub link, which you'll be able to see in a moment. So you've probably got a whole bunch of really, really intelligent, well thought out questions. But one of the common questions you're probably going to simply have is why? Why go through this? What are you actually trying to solve here? And it's probably worth by thinking about some of the vision that you've probably seen when you're talking about events is, sorry, I'm just going to move this out of the way. Events are everywhere. Event-driven architecture, if you pick up the Wikipedia definition, is that architecture paradigm promoting consumption detection of events. And if you start getting exposed to event-driven architecture, you very quickly get into this sort of world of, well, is this payment records? Is it sentiment analysis on Twitter? Is it web stream analytics? Is it fraud analysis? Event-driven architecture are those things, but it's also this whole world of being able to take messy data and think through styles of events that you get in the real world, including object detection. Object detection, when you're talking about machine learning, vision, classification, is another type of a stream of events. And once you have a stream of events and event-driven architecture, you have to start solving some real world and some quite interesting challenges. So today I wanted to take you through just a few of these examples and give you an idea of how some of the problems that you might get along the way. So this was my mental model of how to build an event-driven system when identifying socks. And so this was my mental model of how I'd actually go about solving this problem. You hold up a blue sock, it gets identified as blue. If you hold up a black sock, it gets identified as black. If you hold up a green sock, it gets identified as green. And this was my mental model of how you'd go about and build like a machine vision processing engine and some event-driven architecture under the covers. But that's not what happens in reality. What happens in reality is that you have these very, very dumb and not always correct machine classification things that are constantly parsing frames from a video feed, and they're sticking out a whole bunch of classification events, and sometimes those events are correct and sometimes they're incorrect, and it just becomes a sort of an avalanche of events that comes through the ether. So this is typically what happens. If you hold something up in front of a machine vision library, you're going to get a whole bunch of classification messages. So if you hold up a blue sock, you might get 1, 2, 5 blue events. And then as you remove from a frame, you might hold up an orange sock and you might get, you know, a whole sequence of events that represents, you know, with some confidence that you've identified an image that's orange. And then you might just get sort of aberrations as things go in and out of the frame. And remember, this is a toy problem. This is identifying something that's very, very simple in a very constrained environment. But this gets much harder when you're doing proper machine learning in the real world. You end up with a much messier stream of events. So this is a simplified example of some of the problems you get in the real world, where you've got to handle removed spurious messages, you get phantom events, and your ultimate goal here is to clean that stream, clean up that event stream, and actually get some real world sentiments off the back of this. So we're going to be covering a lot in the next 20 minutes or so. So kind of what I wanted to do, just to frame everyone's thinking here, is to start at the finish and then we'll work backwards. So what I want to show you here is literally the end of this product, where we're going to hold up a sock in front of a camera, a whole bunch of machine learning and Kafka stuff happens, and then you ultimately get a classification that says this sock, its paired sock, is this far down the stack. And what this actually looks like, here's hopefully a screen grab, which will show you what this looks like. Holding up socks, you'll see a bit of overlay on the confidence that that sock has been matched. And then that text down the bottom shows you where its paired sock is within your stack of socks. So what I'm showing you here is completely offline. Once this model is trained, this is all completely offline and it's running on a localized cluster. And although this seems like a silly example, you can think of all of this technology as being used, and I've used it on customer sites where this actually gets scaled out in the hundreds of endpoints. So what you're seeing here is an example of a camera, but you can just mentally think that there's nothing different here between one camera and thousands of cameras. One event source versus thousands of event sources. So that's the end of this. So let's get you through how we're actually going to build this today. Let's dive into that bit in the middle, the machine learning and the Kafka stuff right in the center. So this is our architecture diagram. We're holding up socks. We're going to be using a bit of physical hardware, which I'll get to in just a moment, which is called a deep lens. Then we'll be putting those payload events into an MQTT broker. And then we're going to be using a whole bunch of Kafka and Kafka-related technologies, including Kafka, Kafka Connect, KSQL to do stream level transformations, and ultimately do all of that stream cleanup, stream processing, and ultimately realize all the events. So we've actually got a realized stream. So let's dive into that first part. How do we actually take a real world object in front of a camera and actually get a level of confidence of what that sock actually is? And so firstly, I need to introduce this. This is called an AWS Deep Lens. And these are pretty cool. They're about $300, $400. I'm sure if you ask Drew, he'll get you one at a discounted rate. And these are sold as a deep learning enabled video camera, which sounds really, really cool. But essentially you're talking about, it's a hardware device with a 4 meg video camera. It's got embedded, fairly beefy Atom processor. It's got 8 gigs of RAM. It runs Ubuntu under the covers. And essentially it's got some specialized hardware, so you can actually deploy things like MXNet and TensorFlow models, and it runs quite nicely. The takeaway here is that this, once you deploy the model onto the camera, it runs completely standalone. There's no, once you've done the initial setup, there's no need to be connected to the internet, and there's no particular cloud technologies other than first-time training. And it's here that I kind of need to make a quick confession. I'm not a machine learning image expert. I'm not a data scientist. I'm a data engineer at the end of the day, and I kind of have to work alongside the cool kids who are the machine learning engineers. So something like this is a great sort of stepping stone to actually get across some of those concepts. So supervised, we're going to be using something called supervised image classification. And the takeaway here is that you need to do a lot of first-time classifications of the image to get the model up and running. So you need training data, and then you need to prepare the training images. And ultimately, in my case, I needed to take a lot of photos of socks. And that's as exciting as it sounds, where you are literally getting a camera on top of a tripod and taking, in my case, 30 to 40 photos of each sock type, and I ended up using about 12 different sock types. So this was a fantastic way to spend a Sunday afternoon, and it makes you really, really interesting at dinner parties when you're talking about your hobbies, which involve taking photos of socks. So this is all sort of necessary because what we're going to be doing is training an image classification model. That classification needs to be able to take socks in front of a camera and work out what's actually happening under the covers. Now, I use something called transfer learning. Transfer learning takes the leverages the learning gain from a classification model that someone else has used, and it allows you to sort of bootstrap that learning into your own unique classification model. So it would not surprise you if you Googled the words, has anyone come up with a sock classification model? No one's actually done it, but people have built models that classify bikes and cars and trains and dogs and cats. So you can take one of these models that's really, really good at classifying one thing, and then you can use transfer learning to take a generalized model and make it quite hyper specialized for what you actually wanted to do. So that's what I did. I used transfer learning to take an off-the-shelf classification model, which was good at finding bikes from cars to shoes, and actually used it in combination with my images to help bootstrap it. So it got good at classifying socks. And the steps for a deep lens are pretty straightforward. You fire up Amazon SageMaker, which at the end of the day is a sort of a hosted Jupyter notebook, brought down a generalized image classification algorithm, and then applied my training set over and above it. So I could train up a bespoke classifier image. I can then just test the validity of that by just deploying this classifier very, very temporarily locally onto an EC2 box and just fire up what's called an inference function, which is just a fancy way of saying I ran Python in a loop. And then took a few still JPEG images just to test the validity of the images. And once I'd convinced myself I'd actually managed to build a sock classification algorithm, I could then get onto the serious thing of taking that model and deploying it to a hardware device. So this is where we're talking about taking the model and a running function. So we can actually deploy that both to the deep lens, so it can actually do some smart things offline. So what I want to do is run all images captured by the lens of the deep lens through a camera and apply it as often as I can through that classification model. So I also want to get a bit of real world feedback on what's actually happening in the camera. So I've got it all set up so you can point a web browser to actually get a feed from the webcam and use OpenCV just to do that text overlay of what the camera thinks it's found or what the classification model has identified on the screen. So OpenCV is a fantastic open source library. There's nice Python wrappers, and it's very, very straightforward to do text overlay on top of an image. And what I actually want is that's helpful for a human to see what's going on, but I actually want to make sure that the images are making it out of the camera and are then addressable in a downstream system. So one of the things that the deep lens does out of the box is it allows you to write events to an MQTT topic, which I'll get onto in a moment. This is what the inference Lambda function looks like actually on the hardware device itself. It's a little bit longer than this, but not much longer. And if you can, I don't know if you can see this on your screen, essentially this is just a Python loop. And you can find that pretty much what it does is it opens the camera, runs it in video mode, and every frame that comes from the camera goes through that model function, and a classification score is applied to that image, and then it does it again, and it does it again. And it does this 10, 20 times a second. in a loop that goes on forever. And every time that classification model runs on every single frame it encounters, it passes the result of that classification model out to an MQTT endpoint. And I just want to stress again that this is all running locally on the hardware device itself. There's no cloud involved at this point. So every frame that the hardware camera is seeing is being analyzed on device, and that's ending up on an MQTT topic. So I've said MQTT a few times, so not everyone's going to know what that is. So MQTT, it's a lightweight TCP IP protocol. It's got a super small footprint. It's really, really great for power constrained devices or compute constrained devices. And it's low power, and it kind of acts more like a key value store. So if you think about a temperature sensor in a warehouse, it typically pukes out its results to an MQTT topic. The device is quite power constrained. It's not going to care if the messages are, there's no guaranteed delivery with MQTT. It's just best endeavor, and it's no more complicated than like a distributed Cassandra or something like that. It's just a key value store. Confusingly, a lot of the language used by MQTT producers, consumers, topics are exactly the same words that Kafka users use. So it gets a little bit confusing when you're talking about an MQTT topic as opposed to something like a Kafka topic. Just be conscious, MQTT at the end of the day has no stream processing. It's got very, very lightweight compute constraints, but it's got no smarts at the end of the day. So MQTT acts like a distributed key value store, whereas Kafka gives you that sort of complete streaming platform. So far we've got ourselves socks that sit in front of a camera. The camera runs its inference function, and it's puking out the results to an MQTT topic. That's fine, but remember all of this, there's no smarts, there's no time involved in that. So what we now want to do is actually build out this framework so we can actually add recognition to the socks and actually start doing some stream level processing. So our first problem is getting the stuff, getting those payloads out of MQTT and into Kafka, and that's easily achieved with something called Kafka Connect. So let's talk about how we get stuff into Kafka. So Kafka Connect, if you've never come across it, is this fantastic framework for essentially getting stuff in and out of Kafka. It makes it really, really simple to define connectors that move large data sets in and out of Kafka. Kafka Connect's scope is extremely narrow. It only focuses on copying streaming data to or from Kafka. It doesn't handle anything else like stream processing, but the framework itself is super solid. It handles distribution, scaling out, scaling in, start, stop, resume, offsets, all of that kind of good stuff you want out of Kafka. And it's a super opinionated framework, highly flexible. So if you ever need to get stuff in or out of Kafka, don't write it yourself. Look for a Kafka Connect framework that's going to do it for you. Kafka Connect essentially has two flavors. Kafka Connect sources takes something from the outside world and lifts it into Kafka. Kafka Connect syncs stuff, takes stuff that's stored in Kafka and streams it somewhere else. To get Kafka Connect up and running, you pretty much deploy a bit of configuration and you give it a jar file that's specific to the data set that you're dealing with. So in my case, I have an MQTT source. So I need to deploy an MQTT driver, which is a sharded jar, off to my Kafka Connect cluster. With that stood up, it then allows me to just, with configuration, allow my MQTT source to be streamed in near real time into my Kafka cluster. So that was a lot of stuff. And if you've had exposure to Kafka and Kafka Connect, you're probably used to using a REST endpoint for configuring Kafka Connect. And that's fine and valid. But I'm a big fan of using KSQL DB to solve a lot of streaming challenges. And KSQL DB also has a new tool, a new capability where you can actually do all the configuration of Kafka Connect through KSQL DB itself. So what I'm actually doing here is using a SQL dialect to take care of all of the processing that I'm going to be doing on top of the stream and all of the configuration I want out of my Kafka Connect cluster. So KSQL DB essentially has a really cool feature called connector management, which I'll drill into in just a moment. So what we actually want to do here is remind ourselves we've got sort of key values in MQTT, which are constantly being overridden. We want to take those as quickly as we can and put each new event, each new occurrence of a tuple into our Kafka cluster. So we've got then that immutable stream, so we can do stream processing over time. So the first thing that we're going to do is use KSQL CLI to connect to the KSQL server to issue commands to the Kafka Connect cluster. Now, all of this is hidden from you, but when you're typing commands at the KSQL CLI prompt, you kind of just have to remember, I'm issuing these commands which are ultimately hitting the Kafka Connect cluster. I'm only calling this out because if you're doing things like deploying jars, which are MQTT specific, or you've got secrets or configuration, it all has to be in relation to the Kafka Connect cluster, not the KSQL cluster. And so that's just one of those first time head slapping moments when you realize that the reason that you can't see your jar is because you deployed it to the wrong physical box. Again, if you use Kafka Connect before, this syntax might look quite similar to, familiar to you. But what I'm going to be doing is actually issuing the commands to get Kafka Connect listening into my MQTT source by issuing a KSQL command. This is pretty much the syntax. What's kind of neat here is all you have to do is give it a class path, the name of the URI of your MQTT endpoint, username, password, those kind of credentials, and give it a value converter, the source MQTT topic and your destination topic. And once this is deployed, this will run forever. You can kill off nodes of your cluster, you can kill off MQTT, you can wake things up, you can move things around. Once that's up and running, this stuff's super flexible, super scalable, and it has all the advantages of a highly distributed system without you actually having to do much other than issue this configuration in the first place. So it makes you look like a genius, because you get a lot of resilience and flexibility, and all you've had to do is issue 8 lines of KSQL command. You may be wondering where that comes from. This is a neat feature of KSQL DB, and in fact, it's a neat feature of Kafka Connect. If you've got secrets and you want to take them out of band, you can just put either like a call to a KMS store or a HashiCorp vault. Here I'm just using secrets which have been externalized in another file. So my username, password, and URI, I can actually store somewhere else. So if you're in a big enterprise, you'd use key management for this. If you're just hacking around on your own little server, you might just want to put it out of band in a little credentials file. Having said all of that, we're now on our merry way. We've now got our image processor taking images in, and we can test that those payloads are in fact coming into Kafka. So we can just use a CLI command like Kafka console consumer, point it to your Bootstrap server, and just double check that the messages and payloads are really coming in. So as I'm holding up socks, it's likely to be finding those as we go. So that gets our data from our camera into our Kafka cluster, but now we actually have to solve the real problem of how am I going to clean up these messy payloads and how am I actually going to pair my socks? So let's do the stream processing now. So let's think of our goal. We want to create a stream over and above our JSON. So that's what our JSON looks like. We can actually define in KSQL DB just a quick schema around it by using a dialect like this. If we use protobuf or Avro, would have done this definition up front. In this particular project, I was just using on the wire JSON, so I needed to define the schema after the fact, but this is pretty much the syntax that you'd need. This gives you a bit of an idea of what those payloads actually look like over time. So if you can think about the scenario, I'm holding up, because we've had someone from Microsoft and we've had someone from AWS, I think it's only relevant that I hold up a Google SOC tonight. If you can imagine that when this Google SOC comes in and out of frame, we're going to hopefully get a good classification image when it's in the center of the frame. But as it's sort of appearing into the frame, you might get just a bit of green. And this is what actually happened when I was testing this earlier. I would get a sequence of events saying nothing's there, nothing's there, nothing's there. Then I'd get a very, very quick message saying, oh, it's seen a Mongo sock, which in fact was incorrect. It probably just saw a bit of green. Then it came up with whatever that is, 12 messages that say, yep, it saw a Google sock. And as the sock's leaving the frame, again, I get this misidentification of Mongo. So the deep lens classifier is working really, really quickly, but not all of those payloads are correct. So what I want to do is wrap my stream processing with a level of smarts. So I don't get all of those messages back to back the same, because I don't actually have 91 Google socks. And I also want to get out that noise. I want to make sure that I've got sort of clear, crisp messages before I do some higher level processing. So this is sort of my mental model of what's happening. And what I want to do is when those messages come in, I just want to bound them and do some time analysis around it, just make sure I've got a clear message over time. So my real goal here is to find identical payloads in a rolling 5-second window. And so I can use windowed aggregation in KSQL to bucket these classification messages over time. You can write this in JVM language, but for me, I find that it's much more expressive just to use KSQL and this SQL dialect, which allows you to do time series analysis. And here I just want to say, over a tumbling window of any 5 seconds, just bring me out messages where 5 sequential messages are all the same. And that was good enough for my thing. So I've now got that cleaned up payloads. I've now got the messages being cleaned up so I only get clear, crisp messages. And actually, when I want to find pair messages, I've got access to that exact same stream. So if I pick up a blue sock, a red sock, a blue sock, I want to be able to find out when those blue socks matched one another. And I can use, again, some stream processing, again, using KSQL DB, just to find the matching socks. So in this particular case, I'm using this SQL dialect, which essentially says where the sock has found its friend, mark it as paired. And in the actual example, it will show you where down the stack that sock was found. So if I'm holding up socks just randomly, each sock I pick up will either say this is the first time it's seen the sock, or if the sock had a pair that's been seen previously, it will show me where in that pile that sock has been identified before. And this is what it looks like. So you can hold up socks one after the other, and it will very, very quickly tell you where in that sequence it's found its paired sock. So I'm conscious of time, so I'll blast through the last bits really, really quickly. What did I learn in this? I learned a few things. I thought object detection was going to be easier than it actually was, but object detection at the end of the day is a stream of events. Events are messy at the end of the day. Certainly if you're doing things like real world image classification, super messy. But stream processing doesn't need to be. You don't need to put all the smarts at the endpoint. You can do a great level of stream processing on the wire using an event streaming platform such as Kafka. Kafka Connect is super cool and a great way of integrating systems, and it's super convenient to use something like KSQL DB to do both the transformation, the event streaming, and the connector management. And IoT architecture with Kafka is extremely scalable. Like I said before, this was one camera on one cluster, but this will scale out to hundreds of endpoints using exactly the same infrastructure. And the last thing I learned, and this is an important thing that I think we should all take away, is that sock sorting doesn't make you interesting at parties. So yeah, maybe talk about the weather or politics before you launch into that. And with that, I might ask, are there any questions?
Well, first of all, massive round of applause to you, Simon. That's super interesting. You know, another awesome IoT sort of machine learning project. Definitely, I think I can speak for everyone in saying that we all love your talks tremendously. So thanks again. Yeah, if we haven't had any questions come through on the chat so far from what I can tell, but yeah, I think a lot of praise. Drew says, unreal, really interesting, Simon. Great use of deep lens. So Alice has asked, so is this fully push driven? I believe.
Yeah, so I think that the correct language is it's event driven. So so Kafka Connect is responsible for finding any new unprocessed messages. So the thing with Kafka is it's all up to the producer and consumer to take care of itself. That's why it's so resilient to being killed or scaled. So if an event appears, the consumer group is responsible for bringing it down. And once it's brought down, the message, it's marked as done. So it's almost, if you're trying to mentally think of it, it's almost like pull architecture rather than push architecture. But your takeaway here is a lot of this stuff is taken care of for you. So in latency, this is done in milliseconds between messages arriving and being processed. Another one, are you using this at home in production? How much has your SOX usage dropped during the pandemic? That's a great question. Yes, it turns out that now I'm at home, I do have to do more of the lion's share of the household laundry. So yeah, this is, when I'm talking about scaling requirements, yeah, I'm going to have multiple deep lens cameras to do all of the household laundry. Great that you've managed to get that high availability up. Alice has got another one. I use reactive extensions and that does not offer distributed processing, but Kafka can. Yeah, I can't speak for reactive processing, but I can speak for this structure. I've deployed it to sites where there's hundreds of endpoints, and yeah, it's scalable. Yeah. Cool. Awesome. Yeah, well, thanks again. Actually, there's Tusha. He's got a question. Very interesting talk, Simon. Have you played with AWS Greengrass that supports ML inference at the edge too? Yeah, so Greengrass is almost like an opinionated Python library. And yes, so the answer is yes. And in fact, that runs, I think it's called Greengrass SDK IoT. Don't quote me on that. But it's a way of actually leveraging some of like the basic things like bounding boxes. So a lot of that sort of smarts is available in the cloud and is mirrored here. So you can, I've got to say, when it works, it's really, really cool because you can write exactly the same stuff in SageMaker and have it running on the deep lens, which is super nice when all of the libraries line up. Yeah. I appreciate that challenge. So Drew's asked, so is this going to IoT Core, then a rule, then to Lambda, and then to Kafka Connect? Is that how you're doing it, or are you doing it all locally? No, it all happens locally. So just for clarity, the hardware device is writing to an MQTT endpoint locally, and that's going straight to a local Kafka cluster. So there is no Lambda function. And there is essentially no cloud involved in this. Very good. And are you using like a CI/CD pipeline to deploy all the components that's from Francisco? There was one, and then it broke, and then I didn't fix it up. So full end-to-end testing. Full end-to-end test. Yes. Yes. Everything. Absolutely. Trunk-based development, pair programming. It was all there. Ah, amazing. Yeah. I would not have expected anything less, but. Again, round of applause. Simon, thank you so much again. We're just going to flick over to a couple of slides just to do a few more shameless plugs of different things happening. So I'll just do that real quick. So again, wanted to thank the sponsors for our data engineering Data Eng Bytes conference. And so Snowflake, they were there right from the beginning. MongoDB likewise, Fivetran, Canva right from the beginning. ThoughtWorks, Instacluster, awesome companies. So thank you so much for sponsoring us, being able to sort of provide a free conference, which we hope is going to be super awesome on the 20th and 21st of August. Yeah, couldn't have done it without such great support. I'm just going to flick through a few of these. Thank you so much again to all of our awesome presenters and our awesome MC, Francisco Liwa. Yao Data, get a ticket to it. I'm going to be there. So I think Yao conferences are just incredible. Like the
the speakers that they find and everything. I think it really encourages you to think differently about data. And so I do encourage anyone. I think they've got like a special pay what you can ticket price. So if you can't afford $100 ticket, just, you know, put something down. I'm sure, you know, they won't mind. And yeah, get along. I'm sure you'll learn some great stuff. We've got Claire Carroll. She's awesome. Greg Root, he runs data engineering at Canva. So, you know, like Dennis Bauer, she's like using serverless, another passion of mine, to solve, you know, some genomics in regards to COVID-19. So some really impressive folks that are going to be presenting there. And of course, DataEng Bytes, we've got this awesome team. So, you know, thanks so much for all your support. I think we've sold well over 100 tickets so far. So also don't forget to submit it to the CFP if you've got a really cool talk that you'd like to, you know, let us know about. So thanks again. Thanks to all the team that helped put this meetup together. It's not just me, it's a great bunch of folks. So thanks you so much, and see you next time we get together.
Thanks, everyone. Thanks, Peter. Thanks, Simon.
Thanks, everyone, for coming.
Thanks, everyone. Bye.
Thank you. Bye.
Thanks, Drew. Bye.
All right, signing off.